Good evening, ladies and gentlemen. Can anybody see and or hear me?
Yes.
Okay, all right. That's good to know. All right, we're going to do a couple of sections today, 3.1 and 3.2. Now, I did send out the quiz, but I found out that I sent the exam to my other class by mistake. And so for that reason, you did not receive the exam, correct? All right, so you did not receive the exam. All right, so I will send the exam to you this time, and I do apologize. And I'll give you till like Friday by midnight to get that exam done, and I'll email you exactly what I want you to turn in for your homework too. All right. So I do apologize for routing that exam to the wrong class, ladies and gentlemen. But I'll give you till Friday midnight to get it done, 11:59 p.m. Friday. And I'll also indicate what I want you to send in for your homework, okay? All right. 3.1 and 3.2 is going to open up a brand new chapter for us. And that is involving working what's called the XY plane. And we are going to learn how to not only plot points in the XY plane, but we're also ultimately going to learn how to graph linear equations in the XY plane. So that's where our time is going to be spent in chapter 3 for that topic. If you can get your hands on some graphing paper, ladies and gentlemen, that would be very helpful. Let's see if we can begin to go to section 3.1 now. We'll get your textbook here for you. Okay, so the first thing we're going to need to do is introduce ourselves to the XY plane. All right, so section 3.1 is where we will begin. Okay. All right, so welcome, ladies and gentlemen, to the XY plane, or sometimes it's called the Cartesian coordinate plane, or sometimes it's called a rectangular coordinate plane. I just call it the XY plane here. We have two number lines. We have a horizontal number line, which is called the, oftentimes called the x-axis. We have a vertical number line, which is referred to as the y-axis. These two axes partition my single plane up into 4 planes, where they're called quadrants. So quadrant number 1 here is bounded below by the positive x-axis and bounded to the left by the positive y-axis. Quadrant number 2 is bounded by below by the negative x-axis and to the right by the positive y-axis. This is the third quadrant down here. It's bounded above by the negative x-axis and bounded to the right by the negative y-axis. Then we have the fourth quadrant, bounded above by the positive x-axis and to the left by the negative y-axis, excuse me. Notice these tick marks are spaced 1 unit apart on both the x and the y-axis here. The positive x direction is to the right, the negative x direction is to the left. The positive y direction is upwards. The negative y direction is downwards. The point of intersection between the x and y axis has a name. It's called the origin of the xy plane. And to plot points in the xy plane, we always start at the origin. Okay. So what are we going to do in the xy plane? Well, first of all, ladies and gentlemen, the first thing we need to understand how to do is plot what are called points. Or we need to know how to plot what are called ordered pairs. And ordered pairs in general look like this, where the first entry of our ordered pair is called the x coordinate. The second entry of our ordered pair is called the y coordinate. And these ordered pairs translate into a point being plotted in the appropriate location in the xy plane. So that's what ordered pairs look like in general. Let's see if we can plot some ordered pairs now. So this is section 3.1 here. All right, scrolling on down here. Okay, so ladies and gentlemen, to plot the point or the ordered pair 5, 2, we start at the origin, which is the intersection point of the x and y axis. And since the x coordinate of our point is positive 5, that means we move 5 units to the right on the x-axis. 1, 2, 3, 4, 5. And then the y coordinate of this ordered pair is positive 2, which means we move up 2 units. 1, 2. And then we plot the point right here at 5, 2. Anybody tell me what quadrant this point 5, 2 lies in? The first quadrant, second quadrant, third, or fourth quadrant? What quadrant? What quadrant is 5, 2? 5, 2. Right.
The first quadrant.
That's in quadrant number 1 right here. Okay. So 5, 2 finds itself in the first quadrant there. Any questions how we plotted the point 5, 2 in the XY plane? All right, let's see if we can plot some other ones here. This is example 2 in section 3.1. It's always wise to look over the examples of the sections that I cover. I think that helps to solidify the information in your mind. How would I plot the point 3, 4? We start at the origin, and how do I move? I got to move 3 units in the positive x direction and then up 4 units in the positive y direction. So starting at the origin, we move 3 to the right on the x-axis. 1, 2, 3, and now we move up 4. 1, 2, 3, 4, and there's the point 3, 4. It's located in quadrant number 1. Plotting the point 3, -4, we start at the origin. My x coordinate is positive 3. My y coordinate is -4. So starting at the origin, I move 3 to the right on the x-axis, and then I move down 4 units parallel to the y-axis. So start at the origin, 3 to the right, 1, 2, 3, right there. And then we got to move down 4 units, -1, -2, -3, -4. So there is the point 3, -4. It lies in the 4th quadrant. Plotting -3, 4, start at the origin. Now my x coordinate's -3. That means I have to move to the left 3 units, and my y coordinate is +4, so I move up 4 units. Starting at the origin, I move 3 to the left, -1, -2, -3. Now I move up 4 units. 1, 2, 3, 4. Ladies and gentlemen, that is the point -3, 4. It lies in quadrant number 2. Finally, plotting the ordered pair -3, -4. We start at the origin. I move 3 to the left on the x-axis, and then I move down 4 units parallel to the y-axis. So 3 to the left, -1, -2, -3, now down 4, -1, -2, -3, and -4. There is the point -3, -4. It lies in quadrant number 3. Any questions how I plotted these points in the XY plane? Any questions how I plotted those points? Okay. Does anybody remember doing this in some other class? Plotting points in the XY plane. Have you ever done this before?
A little bit, but it was a long time ago.
All right. All right. So it wasn't many moons ago, but the good news is at least you were exposed to it. That will mean that it'll probably be pretty easy for you to get it back together here. All right, so we're plotting points in the XY plane here. Let's see if we can plot some more here. Example 3 in section 3.1. Now, they're not saying plot the ordered pairs, they're saying graph the ordered pairs. Well, ladies and gentlemen, to graph the ordered pairs means the same thing as plot them. All right, so let's try to plot -1, 3. To plot -1, 3, we start at the origin. And by the way, the ordered pair address of the origin is always 0, 0. Because 0, 0 is sitting on the 0th tick mark as far as the x-axis is concerned, and it's sitting on the 0th tick mark as far as the y-axis is concerned. To plot -1, 3, we start at the origin. I move 1 unit to the left on the x-axis, and then I move up 3 positive units. So at the origin, 1 to the left, now up 3. 1, 2, 3, and there's the point -1, 3. I don't know why it's a little blurry like this, but that is the point -1, 3. What quadrant is this point -1, 3 in?
Second.
All right, that's in the second quadrant. Plotting the point 2, 5, starting at the origin, we move 2 to the right on the x-axis and then up 5 units in the positive y direction. So 1, 2, now up 5. 1, 2, 3, 4, and 5. There's 2, 5. And that lies in what quadrant?
First.
First quadrant. 0, 0. Plotting 0, 0. That is the origin. That's right here. The point that sits on the intersection point of the x and the y axis. Plotting 0, -3. We start at the origin. Notice my x coordinate is 0. That means I do not move to the right or left. I do not move right or left. I just move down 3 units on the y-axis. So 0, -3 has me just moving down 3 units. And there's 0, -3. And what quadrant does that point lie in?
4.
Well, actually, that point does not lie in quadrants 3 or 4. We say that point lies on what axis?
Y.
It lies on the y-axis. That point does not lie in any quadrant. It lies on the y-axis. Trick question. Okay. All right. So plotting points, ladies and gentlemen. Let's see if we can go over another one here. Okay. Here's the XY plane. And they want us to do a couple things with this. First of all, they want us to label the axes. So the horizontal axis is oftentimes referred to as what axis?
X.
X.
The x-axis. And the vertical axis is normally referred to as the y-axis. Okay. Now, if you get into the sciences or engineering, oftentimes the horizontal and vertical axis can have all different types of names. But normally for early algebra here, we call the horizontal axis the x-axis and the vertical axis the y-axis. Another thing you always want to do is label a couple of tick marks on both axes to establish what kind of scale you're using. Normally, early algebra has our tick marks spaced 1 unit apart. So 1, 2, 3, etc. So this would be what? -1, -2, -3, etc. Labeling some tick marks on the y-axis, 1, 2, 3, etc. Going down, -1, -2, -3, etc. Okay. All right, let's see if we can plot some points here. Notice point A has the ordered pair address of 2, -7. So we start at the origin, and how do I move? How do I move to plot the point 2, -7?
From the right.
How many places to the right?
2.
2, and then what?
It was negative who?
I moved 2 to the right. That's my X coordinate. Now my Y coordinate is -7. So I moved 2 to the right.
And down.
And I moved down 7 units. -1, -2, -3, -4, -5, -6, -7. There is the point right there. And that is our point A. Okay? What they're calling point A here, 2, -7. Let's try to plot the point -4, -8. How do I plot it? I start at the origin, and how do I move? -4, -8. How do I move?
To the left, 4 places.
4 places to the left. So -1, 2, 3, 4, and then the Y coordinate is -8. So 4
Down.
to the left, and then down 8 units. So 4 places to the left, since my X coordinate is -4. Now I got to move down 8 units because my Y coordinate is -8. So -1, 2, 3, 4, 5, 6, 7, 8. And this point right there, ladies and gentlemen, will be point what they're calling B. Point B. It's located at -4. And what's this tick mark here? -8. -8. So the X coordinate is -4. And the Y coordinate is what? -8. Plotting the point, the next one, which is 6.5, -1. How do I plot 6.5, -1? Notice the X coordinate's a decimal now, 6.5. So I go 6.5 to the right. 1, 2, 3, 4, 5, 6. So there's 6. And here's 7. So 6.5 is halfway in between 6 and 7 right here. And now my Y coordinate is -1. So I move down 1 unit. And there would be the point C there. That is the point whose X coordinate is 6.5, and whose Y coordinate is -1. The Y coordinate is -1. The X coordinate is 6.5. D is the point 3,9. The X coordinate is 3, the Y coordinate's 9. So we start at the origin, we move 3 to the right, 1, 2, 3. Then we move up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 9 is right up here. That would be the point 3,9. That would be D. All right. How do I plot point E? -7.5, 5.5. How do I move from the origin? To the left, 7.5. -1, 2, 3, 4. This is -5, -6, -7, and -8. -7.5 is in between -7 and 8. -8. The Y coordinate of point E is 5.5, so I move up 5.5 units. 1, 2, 3, 4, 5.5 units would be right here. So there would be the point E, ladies and gentlemen. That's the point E. That is the point -7.5 for the X coordinate. And the Y coordinate is 5.5. Okay. Is this making sense how we're plotting these points here?
Yes.
All right. Now, I'm going to plot a point in here, Liz. I want you to tell me what the ordered pair address of that point would be. This is going to be point P. All right. Suppose point P is right here. What would be its ordered pair address for point P?
0, 5.
Remember, it's the X coordinate first, then the Y coordinate.
That's 3, 1.
Start at the origin, you'd have to move over here. What tick mark is this on the X axis?
4.
4.
And the y coordinate is what? What's the y coordinate?
0.
Yeah, this point projects back to the y-axis at 0. It projects to the x-axis at 4. So this would be the point 4, 0. 4, 0. That point lies on the x-axis. So what point is this then up here, which I'll call point Q? What point would that be?
I really, 1, 2, 3. Is it 6? I can't really see. Is it 6?
Well, this is point Q here.
It's 4. I'm sorry, I can see.
All right. So it looks like the x coordinate of point Q would be what? What's the x coordinate?
4.0.
No, the x coordinate. It projects down to the x-axis at what?
It's 0.
0. What's the y coordinate? It's sitting on the y-axis at 4. So Q would be the point 0, 4. Do we understand the difference between the locations of 0, 4 versus 4, 0? We understand the
So
difference.
we start with X first, right?
Yeah, always it's always the x coordinate first and then the y coordinate. Okay.
Okay.
Always. All right. All right. Here's point R. What would be the ordered pair address of point R? What would be the ordered pair address of point R? I'll call this point R, ladies and gentlemen. What would be the ordered pair address of point R? What's its x coordinate? Project this up to the x-axis. What does it hit?
-8.
-8. Now project it to the y-axis. What's the y coordinate?
-6.
-6. So this point here has an x coordinate of -8, and it has a y coordinate of -6. So this point R would be -8, comma, -6. Is this making sense how we're plotting points in the XY plane, ladies and gentlemen? Remember, it's always x coordinate first and then y coordinate. Okay. All right. So what point would this be right here? I'll call it point S. What would be the x and y coordinates of point S here? What's the x coordinate?
6.
The x coordinate.
Is it 0?
0. You project this point up to the x-axis, it strikes the 0th tick mark. What's the y coordinate?
0.
No, the y coordinate.
-8.
-8. Y coordinate's -8. So what is the ordered pair address of this point?
Is it 0? Point
0, comma, what? -8?
Yes.
The x coordinate is 0. The y coordinate is -8. That would be the point 0, -8. Okay. All right, plotting points, ladies and gentlemen, in the XY plane. You think it's something you could do? Graphing paper, like I said, would be very helpful to get your hands on if you can. All right. Let's see here. Oops, hold on. I screwed that up. All right. Let's see if we can do a couple of these here. Problem number 20. Problem number 20, problem number 20 is point number 20 here in the first quadrant. What would be its x coordinate for number 20?
3.
3, and what's its y coordinate?
3.
3. So this would be the point 3, 3, 3, comma 3. Number 19, what would be its x coordinate for point 19?
-4.
-4. What's its y coordinate?
4.
+4. So number 19, that point would be -4, comma, +4. Number 27, what's the x coordinate?
-5,
-5. And what's the y coordinate?
-5,
That would be the point, -5, comma, -5. All right, number 22, what's the x coordinate?
0,
0. What's the y coordinate?
2,
2. That would be the ordered pair of point 0, comma 2. Number 23, what would be the x coordinate?
-3,
-3. What's the y coordinate? For number 23.
0,
0. So number 23, that point would be -3, comma 0. Not 0, -3. It would be -3, comma 0. X coordinate first, then y coordinate. Okay. Okay. So plotting points in the XY plane. All right, let's see if you can plot. Let's see if you can plot some points here. How about points 1 through 8? See if you can make yourself an XY plane on a piece of paper and see if you can plot these points, problems 1 through 8. And we'll check your results. Problems 1 through 8. Next to the point, you can put the problem number like next to it. Like when you plot 3, 2, put number 1 next to that point. Okay. So try 1 through 8 here. This will be classwork number 1. Plot these points in the XY plane, 1 through 8. Classwork 1. All right, did we plot those points? Take a look at them. All right, so I plotted all those points there, ladies and gentlemen, and I put the problem number next to them. Do your points look like this for those?
Can you pull it closer to the screen, please? I'm sorry.
They look like that. Are we plotting these points correctly?
It look like it.
Okay, you getting them? All right, are we getting these plotted correctly, ladies and gentlemen? Because I mean, we got to know how to plot points, otherwise we can't move forward. All right. In general, are we doing okay in plotting points? Yes or no?
Yeah.
All right, I'm gonna assume that we're okay in this plotting points, because I'm being able to plot points in the XY plane. Just remember the X coordinate comes first, then the Y coordinate. The ordered pairs always have to be of the form X comma Y. X coordinate first, then Y coordinate. Okay. All right, well, can graphs be used in the real world, ladies and gentlemen? Do you think they have any applications? They most certainly do have a lot of applications. You know, we all probably have access to a GPS unit. You agree that indicates our location? Because on our planet, you know, there's fictitious north-south lines, which are called longitude lines, and there's fictitious east-west curves or lines called latitude lines. By knowing your latitude and longitude, we can find exactly where you are on planet Earth. You agree? The latitude lines run east and west, and the longitude lines run north and south. I don't know if you've ever had a chance to look at a globe or not, but that's always true. So if you look at Mother Earth here, you'll see lines running this way. These are called latitude lines. And then you got lines that run what? This way, correct? These are called longitude lines. And by knowing your latitude and your longitude, ladies and gentlemen, we can basically locate you on this grid system here that's being used. Okay, so this grid system being used on the planet can pinpoint your location. And if you get lost out at sea, let's say, as long as I know your longitude and your latitude, we can pinpoint exactly where you're at. All righty. So latitude and longitude grid system used on planet Earth is very important for locating objects. And your GPS system makes use of those grid lines to basically indicate where you are at all times, right? Latitude and longitude lines provide a grid system to locate you. All right, let's look at this example here. It says, this is number 50 in section 3.1. It says Judy takes a job at Gigi's boutique, or Gigi's boutique. Her job pays $9 per hour plus $50 per week in commission. The graph shows how much Judy earns for working from 0 to 40 hours in a week. So ladies and gentlemen, the horizontal axis, which is normally called the x-axis, now has a relevant name. It's called the hours worked axis, the number of hours worked. The vertical axis, normally called the y-axis, is now aptly named the amount earned in dollars axis. Notice our tick marks on the x-axis are not spaced 1 unit apart. They're spaced how many units apart?
5.
5 units apart. Notice the tick marks on the y-axis are not spaced 1 unit apart. They're spaced how many units apart?
100.
100. Okay. So this first point here, ladies and gentlemen, which is this point right here, is called the y-intercept. We'll learn about intercepts a little later on in this chapter. It represents the ordered pair. What would be the ordered pair of this first red point here that has 50 underneath it? What's the x coordinate of this point?
0.
0. What's its y coordinate?
0.
Well, they indicate the y coordinate is what, 50 here. See, it's 50. So what would be the ordered pair address for this first point here I'm pointing at? The x coordinate would be what?
0.
0, comma, the y coordinate would be
50.
50?
Yes.
0, 50. Does anybody want to interpret what that point 0, 50 is really saying in the context of this problem? So what is that 0, 50 really saying, ladies and gentlemen, for that first point? How do we interpret what it's saying?
Is it $50?
$50. If you worked how many hours?
0.
0 hours. That means, ladies and gentlemen, we get paid $50 per week in commission. Even if we work no hours, we still get paid that. All right. Can you list for me 3 ordered pairs or points that lie on this graph of this line here, this red line? 0, 50 is 1 point. Can you name 2 other points? 0, 50 is one of them. What would be another point?
15, 185.
Yes, 15, 185 is another point that would lie on the graph. Any other one?
3320.
All right, 3320. Those are 3 points right here. Those are 3 points, ladies and gentlemen, that lie on the graph of that red line, correct? 3 points. Does that make sense then? For part B, question B, how much will she earn for working 40 hours? How much does she earn for working 40 hours? Anybody? We go over to 40 on the horizontal axis, and then we go up till we hit the graph.
410.
She'll earn $410. Do you agree this point projects back to the y-axis at $410? Well, question C, if her check for 1 week is $230, how many hours did she work? $230.
20.
20.
This point right here that says she earned $230, therefore she will have had to work 20 hours. You are correct. Part D, she works 35 hours 1 week, but her paycheck before deductions are subtracted out. Deductions are subtracted out is for $365. Is this correct? 35 hours. She should get paid what amount?
365.
365. Does that seem about right? Okay. All right. Okay. what would be one ordered pair for this graph? Notice the horizontal axis represents the year and the vertical axis represents billions of dollars. Can somebody name for me one point on this graph? One ordered pair?
For year 2005,
Okay,
Yes.
2005, comma. What would be the Y coordinate?
$1,936. Is that thousand? Yeah.
Yeah, that would be 1 point on this graph. 2005 and $1,936.50. So 1 point on that graph would be right there, 2005, comma 1936.5. Okay. So any questions how we're plotting points in the XY plane? Are we good on this? Any questions about the XY plane in general? Well, if we're able to plot points like that, then we can move onwards to section 3.2 now. And in section 3.2, we're going to start working with what are called linear equations in two variables. And in general, these equations look like this. AX plus BY is equal to C, where the two variables are X and Y, and A, B, and C are just numbers. A, B, and C are numbers. The two variables are X and Y. We call this a linear system because both X and Y are raised to the first power. So that's a linear relationship or linear equation involving X and Y. Okay. What do you think solutions to such an equation looks like? I mean, we've seen solutions to an equation like this. Do you agree? This is a linear equation in only one variable. We have solved these quite a few times in the past. You know, we've done this. Subtract 1 from both sides, divide by 2, and you get what? X equals 4, correct? This is a linear equation in one variable. We're now going to turn our attention to linear equations in two variables, X and Y. And ladies and gentlemen, what would be your guess as to what solutions of such an equation must look like? Solutions must be what? Well, they must be ordered pairs. So therefore, solutions to this linear equation in X and Y must be ordered pairs here. Okay. And in order to be a solution to this linear equation, the ordered pair must satisfy this equation. So what does that mean? Well, let's try a problem out here. Here's a question. Which ordered pairs are solutions of the linear equation y equal to 3x plus 2? And I'm going to give her some ordered pairs to work with. 2, 3, 1, comma 5, and -2, -4. Which of these three ordered pairs are solutions to this equation? Well, let's check out the first one, 2, 3. Notice the x coordinate is 2 and the y coordinate is 3. Being the case, we're going to replace the x variable in this equation with 2, and we're going to place the y variable in the equation with 3. So here we go. So replace y with 3. Is 3 equal to 3 times the x coordinate becomes the x variable 2? Is this true or false? Does 3 equal 3 times 2 plus 2? 3 times 2 is 6, 6 plus 2. Is 3 equal to 8? False. Ladies and gentlemen, as it turns out, 2, 3 is not a solution. For the inequality, excuse me, the linear equation of y equals 3x plus 2. It's not a solution because it does not satisfy the equation. Again, what did I do? I replaced the y variable with 3 and I replaced the x variable with 2. Notice it does not check out. Okay. So 2, 3 is not a solution to that linear equation. Do you think 1, 5 is a solution? So the x coordinate's 1 and the y coordinate's 5. So the x coordinate 1 replaces the x variable of 1 with 1. The y coordinate, which is 5, replaces the y variable with 5. So after making our substitutions, our equation would say 5 is equal to 3 times 1 plus 2. Is that true? Is 5 equal to 3 times 1 plus 2? Is that true? It's true. So we would conclude that 1, 5 is a solution of the linear equation y equals 3x plus 2. Everybody understand why 1, 5 is a solution?
Yes.
Do we understand why 2, 3 is not a solution? How about -2, -4? Is it a solution?
Yes.
Well, let's find out. Replace the y variable with the y coordinate, which is -4. Replace the x variable with the x coordinate, which is -2. After making these substitutions, we're going to have -4. Is that equal to 3 times -2 plus 2? Well, we have -4. Is that equal to 3 times -2 is -6? -6 plus 2, is it equal to -4?
Yes.
It is. So therefore, we would say yes, it does appear that -2, -4 is a solution for the linear equation y equal to 3x plus 2. Okay. So we found 2 solutions to this equation, 1, 5 and -2, -4. Do you think this linear equation has any more than 2 solutions, or is 2 solutions it?
It has more.
Both have more. In fact, it has many more. Okay. In fact, ladies and gentlemen, this equation here, y equals 3x plus 2, has an infinite number of solutions. Infinite number. We just found 2 of them. Now, how are we going to find the other ones? And, you know, we're not going to have time to find all the other ones because there's an infinite number of them. What are we going to do? Well, we're getting closer to showing what we're going to do here. All right, let's give ourselves another linear equation in x and y to play around with. How about this one? 2x plus 3y equals 6. They want us to complete the ordered pairs. So they are solutions. All right, the first ordered pair has got the 0 coordinate, but it's missing the y coordinate. So how are we going to, ladies and gentlemen, find the y coordinate of this ordered pair, knowing the x coordinate's 0, if this ordered pair is to be a solution to this equation? How are we going to do this? Anybody? How are we going to find that missing y coordinate?
Could you substitute that x coordinate in for the x coordinate?
All right, we know x is 0, so we can replace the x variable in the equation with 0. So we'll have 2 times 0 plus 3y equals 6. And now we have to solve this equation for y. 2 times 0 is 0, so we got 3y equals 6. Divide both sides by 3. And that implies that y must be equal to what? What's 6 divided by 3?
2.
2. So therefore, ladies and gentlemen, this point here, if it's to be a solution to our linear equation, has to have the x coordinate as being 0 and the y coordinate would have to be 2. We understand how we completed that ordered pair there. Let's try another one here. Given that same equation, they want us to complete this ordered pair where we don't know the x coordinate, but we know the y coordinate is 1. How are we going to find the missing x coordinate here? Anybody? How are we going to find that missing x coordinate there if that point is to be a solution to our linear equation?
Put the y coordinate in.
All right, so we're going to let y be 1. Take 1, substitute it in for your y variable into the equation. Then our equation becomes 2x plus 3 times 1 equals 6. Now we can solve for what? We can solve for x here. How do we solve for x? How do we solve this equation for x here?
Subtract 3.
All right, so we're going to minus 3 from both sides. 3's drop out on the left, leaving you with 2x, and on the right, 6 minus 3 is 3. Divide both sides by 2, and it does appear that x is equal to what? X would have to be equal to 3 halves. So the missing x coordinate of this point, whose y coordinate is 1, must be 3 halves. That point has been completed. This ordered pair or point is a solution to our equation.
Can you just make that 1.5?
Yeah, you could do that if you wanted to. 1.51, or you could, leave it as a mixed number, 1.5, 1, all those would be equal to each other. Sure. All right. Let's see here. So if I give you a linear equation and I give you a partially completed ordered pair solution to that equation, would you be able to find the missing coordinate? You can do that. Find the missing coordinate. So you guys try this one. Given 2x plus 3y equals 6. I want you to complete this ordered pair here. In order for that point to be a solution to our equation, what would have to be its y coordinate? Go ahead and complete that. What did you get for the y coordinate? Anybody?
0.
All right, so replace the x variable with the x coordinate. Doing that, our equation is 2 times 3 plus 3y equals 6. Now we got to solve for y. So we have 6 plus 3y is equal to 6. To solve for y, we subtract the 6 from both sides. Gone. 3y is equal to 6 minus 6 is 0. Divide both sides by 3, and 0 divided by 3 is going to be 0. You are correct. So this ordered pair, if it's to be a solution to this equation, has to be 3, 0. That's your answer. Questions, ladies and gentlemen, how given a linear equation, how we can find a missing x or y coordinate of a point or solution to that equation. Okay. Now that we know how to do that, we can raise the bar a little bit more. Next thing we're going to do here is we're going to learn how to graph a linear equation. Now, what does it mean to graph a linear equation in x and y? This is what it means. To graph a linear equation in x and y means to plot all of its solutions, ordered pair solutions, I might add, in the XY plane. That's what it means, ladies and gentlemen, to graph a linear equation in x and y. It means to plot all of its ordered pair solutions in the XY plane. But as it turns out, a linear equation in x and y has an infinite number of solutions. Infinite number of solutions. Well, how are we going to plot an infinite number of solutions? Well, we're not going to do that. But ladies and gentlemen, in the word linear, you see what word embedded in the word linear? You see the word line. So a linear equation, a linear equation's graph is always a line in the XY plane. It's always a line in the XY plane. So I have a question for you. Since we know it's a line graph, how many unique points do you need in the XY plane to determine a unique line? Anybody? If you have 1 point plotted in the XY plane, is that good enough to determine a unique line that contains that point? What do you think?
No.
No, that's not good enough, because through 1 point in the XY plane, we could put an infinite number of lines. Do you agree? There's an infinite number of lines, ladies and gentlemen, that can be drawn that go through or contain that point. No, you need more than 1 point. Need at least, how many points? At least 2 unique points. Unique means they're not the same point, they're different points. You need at least 2 unique points to determine a unique line in the XY plane. So you need bare minimum at least 2 unique points to determine a line in the XY plane. Better, however, is 3 points. So we should find 3 ordered pair solutions of a linear equation if we are going to successfully graph it in the XY plane. 3 points instead of 2 points. So what's the big deal? Why can't we just use 2 points? Why isn't it good enough? Well, 2 points is okay as long as you're very accurate in graphing the line through the 2 points. But if we do a sloppy job in putting a line through 2 points, we could get in trouble. For instance, if I plotted 2 points for a linear equation in the XY plane and these were the points. You agree, ladies and gentlemen, if we're not careful, we could have different lines with different slants go through those points. If we're very sloppy in putting a line through the points, we could have a line that looks like that. Or we could have a line that looks like what? Like this. Do you agree these lines have radically different slopes to them or slants to them?
Yes.
2 points are not good enough if you want to be accurate. If you are going to use 2 points, you have to make sure the line goes dead centers right through both points. That's the important thing. The line has to go right through the center of both these points. Anything less than that, you're going to have maybe an inaccurate graph. So just make sure you put the line right dead center through the points. To help, circumvent this potential issue or problem, it's better to plot not 2 points, but to find what? 3 points. Because if you have 3 points, then it's very difficult to mess this up, okay? 3 points are better than 2 points. Try to go with 2 points instead of 3. All right. Well, so let's try this out. Let's try to graph a linear equation. Let's try to graph x plus y equals 5 using what is called the table method. Table method. And as the name suggests, we're going to make a table. And we're going to label these columns. The first column is going to be called the X column. The second column is going to be our Y column. And the third column, we're going to call our ordered pair column, next comma 1. All right, so I'm just gonna, now, we can generate an infinite number of ordered pair solutions to this linear equation because there's an infinite number of choices that we can choose for x. There's an infinite number of real numbers. So we can choose any value for x, ladies and gentlemen, whatever value we choose for x, the y value will depend upon that choice according to this equation that embodies the relationship that exists between the variables x and y. Because we can choose any value for x, you might want to choose values that are close to the origin so that they're easy to plot. In other words, you would never want to choose, in this case, like x being equal to like 1 million. Do you agree, ladies and gentlemen, that's not a good choice for x, 1 million? you're gonna have a very difficult time trying to plot that point in the XY plane. Your x-axis would have to go all the way out to 1,000,000 out here, 1,000,000. That's so not happening, okay? So let's choose values close to the origin. How about -2, -1, 0, 1, 2? Let's choose these values. If x is equal to -2, we're going to have to determine what y would have to be equal to according to our equation. So if x is equal to -2, ladies and gentlemen, we are going to have to replace the x variable in the equation with -2. And then we're going to have to solve the equation for y. Now, how do I solve for y?
You could add 2 on both sides.
All right, so we add 2 to the left and we add 2 to the right. 2's dive out on the left, leaving with y. So y must be equal to 5 plus 2 or 7. So when x is equal to -2, y has got to be equal to 7 according to this equation. So we have found one ordered pair solution to this equation. It's -2, 7. Let's let x be -1 now, let's say. If x is equal to -1, what's y going to be? Take -1, substitute it in for your x variable, and then solve for y to find out. So let's let x be -1. Therefore, our equation, after putting -1 in for x, we're going to replace x with -1. So we're going to have -1 plus y equals 5. And now we solve for y by adding 1 to both sides. Y is equal to 6. And so, ladies and gentlemen, if x is -1, y has got to be 6. Hence, another ordered pair solution to this equation up here would be -1, 6. That's another solution. If x is equal to 0, y would be equal to what? If I replace the x variable with 0, we would have 0 plus y equals 5, which means y would be 5. 0, 5 is yet another ordered pair solution to this equation. If x is equal to +1, what would y have to be? Take 1, substitute it in for the x variable, and then solve for y. So we'd have 1 plus y equals 5. Now we solve for y by subtracting 1 from both sides. Y would have to be a +4. So another point that would be a solution to that linear equation would be 1, 4. Finally, if x is equal to 2, you guys find this one. If x is 2, what would y have to be? What would y have to be if x is 2?
3.
3.
Y would have to be 3. So therefore, if x is equal to 2, our equation becomes 2 plus y equals 5, solving for y now, subtracting 2 from both sides. We therefore will get y is equal to 3, so you are correct. 2, 3 is yet another ordered pair solution to our equation. How many, ladies and gentlemen, solutions have I cranked out for this linear equation? How many solutions have I found?
5.
5. Now, what are we going to do with these points? What do you think we're going to do with them?
Graphing.
We're going to plot them in the XY plane, ladies and gentlemen, and then we're going to look at the graph of this linear equation. So what you need to do now is get your hands on some graphing paper. And do we know what graphing paper looks like?
Yes.
Yes.
Where are you going to get your hands on some graphing paper?
You can get it at craft stores or dollar stores.
Oh yeah. You can get it at craft stores, you can get it at dollar stores. You can
Walmart.
any office outlet, correct? Like Office Max or Office Depot or
Yeah, anywhere that sells school supplies too.
yeah, you can buy it at Walmart, you can buy it at, Myers probably, you know, you can buy it just about anywhere. Except I don't think you're gonna find it at like Kroger's grocery store. I don't think you'll get it there. I've never seen it there. I could be wrong though. I don't think they have it there. So anyways, I know we gotta graph these, you know, these points here, and I would strongly recommend that, you know, you get your hands on some graphing paper. I tried to print out some graphing paper, but my printer just refuses to cooperate today. It told me to take a hike. So don't worry, I'll get even with my printer. Don't worry about that. But how are we going to plot these points? Well, we might have to make ourselves a XY plane here. But if you're going to do so, I would strongly recommend you use a ruler at least to have some sort of accuracy here. But graphing paper would be the better way to go by far, ladies and gentlemen. So we're going to call this our x-axis, and we'll designate this as our y-axis. Always put arrows on the ends of your axes because they have to go in both directions forever. Then the next step is you want to evenly space some tick marks along your axes here. And that's where a ruler, like I said, comes in really handy to keep these tick marks evenly spaced. Otherwise, if you don't use a ruler, if you try to space these freehand, good luck. It usually turns out to be messy. That's why at least use a ruler if you're not going to have graphing paper, and at least evenly space these tick marks. We will assume that they're spaced 1 unit apart on both axes, okay? All right, ladies, I'm going to help me plot these points here. I got some points that I need to plot. I got the point -2.7, whoops, -2.7. So I start at the origin and I move what, 2 to the left? And then
Yes.
I got to move up what, 7 units? So 2 to the left and up 7. Wow. Unbelievable. Let's see here. Maybe if I split these up here and put some more tick marks on here. So I'll call this 1, I'll call this 2, 3, 4, 6, and 7. All right, so I go 2 to the left and then up 7. So 2 to the left, up 7, right here in the second quadrant is going to be my point -2.7. -1.6, we start at the origin, go 1 to the left and then up 6. -1.6 is right here, also in the second quadrant. 0.5, we start at the origin and we do not move right or left. We stay right on the y-axis and we move up 5 units. So 0.5, we stay on the y-axis and just go up 5. 1, 2, 3, 4, and 5. Right here. 1.4, we start at the origin, move 1 to the right on the x-axis, and then move up 4 in a positive y direction. So 1 to the right, now up 4. 1, 2, 3, 4. Does it appear, ladies and gentlemen, that these points are lying on a line? Does it look like they lie on a line? We want to plot the point 2, 3. Start at the origin, go 2 to the right, and then up 3. 1, 2, and then what? 3. Does it look like those points lie on a line, straight line?
Yeah.
They should, because this is what kind of an equation we're graphing. It's a linear equation in x and y. And because of that, its graph must always be a line in the plane, meaning its solutions, its ordered pair solutions must always lie on a line. Take a ruler, put a line through those points, put arrows at the end of the line, and ladies and gentlemen, we are done. This line represents the graph. We have just successfully graphed the linear equation x plus y equals 5. And we used what method to graph it? It was called the
Table method.
Table method. It was the table method. We chose values for X, computed what Y would be, and in doing so, we cranked out some ordered pair solutions for the linear equation. We plotted those ordered pair solutions, put a line through those points. We have the graph of that linear equation. This makes sense how we graph this linear equation. So how many points are on this line? How many points are on this line, Liz Owen?
5.
Only 5? Do you think there's any other solutions or points on this line?
Yeah, some more.
Well, that's a solid line, correct? That means, ladies and gentlemen, there's an infinite number of points or ordered pairs on this line. Infinite number. I just plotted 5 of them. There's an infinite number of other ones. This line goes forever this way and goes forever what? Up this way. That's why this linear equation has an infinite number of ordered pair solutions. We just found 5 of them. But there's really an infinite number of other ones. Infinite. So many you can't even enumerate them or count them all. It's too many. This linear equation even has some ordered pairs that have very messy X and Y coordinates, fractional or decimal Y coordinates, or X coordinates. I just found some nice points, nice ordered pair solutions. That's good enough to graph it. You can find some messy ones if you want to. You could let X be equal to like 2.718 and then solve for Y, which would also be a messy decimal. But in reality, there's an infinite number of points or ordered pairs on this line. So if I pick a point in the XY plane, would this point right here be a solution to my equation? Is this point here a solution to this linear equation?
No,
How do you know that?
it's not on your line.
It doesn't lie on the graph of the linear equation. To be a solution to this equation, ladies and gentlemen, the point has to be on this line. Has to be, or else it's not a solution to that equation. So this point here is not a solution. Not a solution. Okay. Any questions how we graph that linear equation X and Y? Maybe we could try another one, huh? Let's try to graph Y equals 3x minus 1 using table method. And as the name suggests, we're going to have a table. X column, Y column, then ordered pair column. Give me some nice values for X, ladies and gentlemen. Give me some nice values for X so I can generate at least 3 ordered pair solutions to this equation. At least 3 points. Does anybody want to choose a value for X that might be something like this?
No,
You could. You could choose a value of X like this. You're going to get a messy Y value, but I guarantee you there is an ordered pair of points sitting on the graph that has this for its X coordinate. But why do that when you can choose nice values? Give me something nice for X.
7.
What would be some nice values for X?
1.
1. Any others?
What?
I can think of one even easier than 1 to work with.
Outside. It's a dog out there. She not going out there. The dog in the gate. I wouldn't give a fuck. I heard how that motherfucker was barking and running. Pit bulls bite.
All right, ladies and gentlemen, I'm going to choose 1. I'm going to choose 0. What else?
3.
3. All right, that's good enough. If X is 1, what's Y? If X equals 1, we got to find Y. So replace X with 1. So Y is equal to 3 times 1 minus 1. Y is equal to 3 minus 1. Y is equal to 2. So 1, 2 must be one ordered pair solution to this equation. We found 1. Let's let X be 0 next. If X is equal to 0, we got to find Y. Take 0, substitute it in for the X variable, and your equation now is Y is equal to 3 times 0 minus 1, which means Y is 0 minus 1, which means Y is negative 1. So 0 and negative 1 is another solution, ordered pair solution to that equation. Let X be 3. If X is equal to 3, Y would be equal to 3 times 3 minus 1. Y would be equal to 9 minus 1. Y would be equal to 8. So 3, 8 is yet another solution to this linear equation. And we could go on till the end of time, you know, choosing any value for X. Whatever value we choose for X, Y would have to depend upon it according to this equation. Do we have enough points, ladies and gentlemen, to plot and determine the graph of that linear equation? Do you think we do?
Yes.
All right, so let's plot these points. In fact, you guys plot these points, then put a line through them. You tell me what the graph of this equation looks like. Go ahead and plot it. Go ahead and plot those points.
We ain't going back outside tonight. Bossy's just gonna be sleeping in the house. So we ain't gonna be outside at night. We can't.
Well, let's see if we can graph those. So make yourself an XY plane here. We'll definitely use a ruler. All right, so we want to plot the point 1, 2 over 1 up 2. There's 1, 2. 0, -1 is going to be down here on the y-axis. 3, 8 is over 3 to the right and then up 8. So it's like right about there. Looks like these points lie on a line. Like I'm going to take a ruler and put a line through these points, and you have the graph of that linear equation. That is the graph of y equals 3x minus 1. Did we all get that correct?
Yes.
Okay, that's the graph. All right. We see how we're graphing linear equations by using the table method here. All right, so that's the graph. What if we had an equation that looked like this? What if I had an equation that said x is equal to 3? What would the graph of this look like? Graph of x equals 3. You're probably wondering where the y coordinate is. Well, technically the y coordinate is there. It's just saying that this is really saying x plus 0y equals 3. But 0 times y is as good as if this isn't even here. That's why x equals 3. Now, what does the graph of x equals 3 look like? Well, it's pretty simple. It's going to be a vertical line. And this vertical line is going to have to go through the x-axis at what value? What do you think?
+3.
That's right. The graph of x equals 3 is going to be a vertical line, and it's going to go through the x-axis at 3. That would be its graph right there. The vertical line goes through the x-axis at 3. That is the graph of x equals 3. Makes sense, because any point on this vertical line is going to have an x coordinate that's always 3. Always 3. The y coordinate could be anything, but the x coordinate's stuck at 3. That's why it's a vertical line. On the other hand, what if we had the graph of y equals like -2? What's the graph of y equals -2 going to look like? The graph of y equals -2 is always going to be a horizontal line. And this horizontal line is going to have to go through the y-axis at what value? At -2. So this graph of y equals -2 is going to be this horizontal line that goes through the y-axis at -2. That would be the graph of y equals -2. It's just a horizontal line. So we got two extreme cases here: vertical line, horizontal line. Any questions about those? One last possible scenario is, what if you had an equation that had a fraction in it, and I wanted you to graph it? Like if I had y is equal to like 3/5 x plus +3. And I wanted you to use the table method. Well, again, we make ourselves a table here. X column, Y column, and then we got our last column is our ordered pair column, X, Y. Now, because we have a fraction being multiplied by X, it would be wise to choose values for X that are multiples of this denominator. So, ladies and gentlemen, it would be wise to choose values of X that are multiples of 5. Why would we want to choose multiples of 5 for X? Because if we choose multiples of 5, we're going to get nice reduction or cross cancellation here. If you don't choose a multiple of 5, then you're going to have a fraction to deal with. And your Y value in all likelihood is going to be a fraction. and it's going to be difficult to plot the point if you have a fractional y coordinate. So my recommendation is to choose these values for x, -5, 0, 5. These are all multiples of 5. So for instance, when x is equal to -5, y is going to be equal to 3/5 times -5, or -5 plus over 1 plus 3. So y is going to be equal to 3 times -5 is -15 divided by 5 times 1, or 5, plus 3. But ladies and gentlemen, since we chose a nice multiple of 5 for x, we get a good reduction here. This reduces down to a nice integer. So what's -15 divided by 5? Just -3. What's -3 plus 3 now? 0. So when x is -5, y would be 0. Hence, this would have to be one ordered pair solution to this equation here. Okay. This has to be one point that lies on the graph of this linear equation. Let's choose x to be 0 now. If x is equal to 0, take 0, replace the x variable in the equation with 0, and now we solve for y. So y would have to be equal to 3/5 times 0 plus 3. But 3/5 times 0 is 0, right? And so we got y is equal to 0 plus 3, which means y is 3. Hence, the ordered pair 0, 3 would be another ordered pair solution to this linear equation here. Or this would have to be another point that lies on the graph of this linear equation. Finally, if x is equal to +5, what's y going to be? Y is going to be 3/5 times 5, or 5 over 1 plus 3. So we get y is equal to, well, what's 3 times 5? 15. So we'll have 15 over 5 plus 3. But what is 15 over 5 reduced down to? 3. So 3 plus 3 is 6. So y would have to be 6. So another ordered pair solution we found for this linear equation is 5, 6. Hence, it would also have to be a point that lies on the graph of this linear equation. So because this denominator of this fraction is 5, you want to choose values for x that are multiples of 5, like -5, 0, or 5, or 10, or 15, or 20, or -10, or -15, -20. All right. Ladies and gentlemen, if you choose 1 for x, that's not a good choice, because if you let x be 1, y is going to be 3/5 times 1 plus 3. Y is going to be 3/5 plus 3. And now you got to get a common denominator, which is 5. So y would be 3/5 plus 15 over 5, which is going to be 18 over 5. But that's going to be difficult to plot. Do you agree? 18/5. See how messy this ordered pair is? If you don't pick a multiple of 5, that's going to be difficult to plot. Not a good choice. You should choose multiples of 5 when you have 3/5 being multiplied by x. If this fraction was 3/7, then we would choose multiples of what? If it was 3/7 times x. If that was a 7 instead of a 5, what should we choose for x? Multiples of 7.
7.
If this was 3/4 times x, then we would choose multiples of 4. All right. So by choosing multiples of the denominator of the fraction being multiplied by x, your life's going to be so much nicer. You don't choose multiples of that denominator, then you're going to have a real messy graph. So to graph this linear equation here, we got our xy plane. And we can plot these points. So to plot -5, 0, we start at the origin, we move 5 to the left on the x-axis. Since the y-coordinate 0, we stay at -5, 0. Plotting the point 0, 3, we start at the origin and stay on the y-axis We don't move right or left, but we move up 3. So 1, 2, 3. There's 0, 3. Finally, to plot the point 5, 6, we start at the origin, we move 5 to the right on the x-axis, and then up 6 units in the positive y direction. So 5 to the right, 1, 2, 3, 4, 5, and now up 6. 1, 2, 3, 4, 5, 6. Up there. Does it appear that those points lie on a line? It does look that way. Take a ruler, put a line through those points, ladies and gentlemen, and you have the graph of that linear equation. That is the graph of y equals 3/5 x plus 3, and we're done. Any questions, ladies and gentlemen, how we're working with linear equations in 2 variables x and y, and how we're graphing them in the xy plane? Any questions? All right, for your last classwork today, I want you to just try to graph one of these linear equations here. So let's see if we can all graph this one. So see if you can graph this equation in the XY plane. We'll call that classwork number 2. All right. Graph that in the XY plane. Let's use the table method too. Okay. So, all right, use the table method. So we're all on the same page. Let's choose these values for x. How about -2, 0, and how about 3? Okay, choose those values. So we're all on the same page. Technically, it doesn't matter what you choose for x, but we'll go with these values so we can all compare our answers.
Is your mic off?
Does your line look like this, ladies and gentlemen?
Yes.
Should be using graphing paper though, so I'll try to post some graphing paper on our Canvas site. You can print it off and copy it if you want. But you can see it's kind of messy when you freehand draw these XY planes here. Very messy. Graphing paper makes for much more accurate graphs. But nonetheless, are we understanding how to graph the linear equation in the XY plane here? So that line is the graph of y equals negative 2x plus 1. That is its graph right there. So any other questions? Ladies and gentlemen, how we're graphing linear equations? You think this is something you're going to be able to do?
Yes.
Yes.
All right, I will get that exam out to you, and it'll be due by midnight this Friday night, okay? Exam on chapter 1 and 2, and I'll also email you and indicate exactly what I want you to turn in for your homework by midnight Friday night for proof of having done the chapter 1 and 2 homework. So be looking for that very important email, including the exam and the instructions for the homework. Any other questions, ladies and gentlemen? If not, I'll let you go. Have a great night.
What was classwork 1 again? I'm sorry.
What's that?
What was classwork 1 again?
Classwork 1 was plotting some points in the XY plane.
Okay, okay, thank you.
Let's see.
The questions 1 through 8.
Yeah, in the textbook, questions 1 through 8, we plotted those points in the XY plane. So make sure you're able to plot those points, problems 1 through 8 in section 3.1, okay?
Okay, thank you.
Those 8 points. Yeah, make sure you can plot them correctly. All right. All right, ladies and gentlemen, have a great night. Hopefully I'll see you on Wednesday.